In section 6.1, we're going to talk about roots and radical expressions. So the main idea here is that corresponding to every power, there is a root. So if I do 5 squared, I get 25. The opposite, taking the square root of 25, I could get plus or minus 5. If I do 5 cubed, I get 125. The opposite would be taking the cubed root, where I would get 5. As dividing is to multiplying, taking a root is to taking a power. So first, let's talk about the nth roots of anything. If a to the n equals b, then a is the nth root of b. But this will kind of differentiate depending on if my power is even or odd. So when in that last example that we just looked at, when I took the square root of 25, I had 2 different answers, plus or minus 5. But when I did the cubed root of 125, I just got one answer. So let's get a little bit more into why that's the case. If n, or your power, is odd, then there is only one real nth root of b, denoted as the nth root of b. Although if n is even and b is positive, there are 2 real roots of b. I call the nth root of b my principal root. I call it the negative nth root of b my opposite root, just for vocab's sake. Also, another really important thing to note here, if b is negative, so if I'm trying to take an even root of a negative number, then there are no solutions or no real nth roots of b. So for example, if I tried taking the square root of negative 36, I get no solution. Or as we kind of talked a little bit about, you could get imaginary solutions. Here we're really just going to focus on real numbers here in the real number system. And then just some vocab before we move on here into some problems. We call this n right here, that would be your index. Whatever's inside your root is called your radicand, and this is called your radical sign. So now, in some examples here, let's find all the real cubic roots of these numbers. A lot of these you could just do in your calculator. So I do the cubed root of 0.008, I get 0.2. I take the cubed root of negative 1,000, I get negative 10. Cubed root of 1 over 27, and I get 1 over 3. Notice here, since I'm taking a cubed root, my n value is odd, so there's only one answer here. I'm not going to have like a positive or negative solution. Again, that's because my root there, I'm going to an odd power, okay, or I'm taking an odd root. On the other hand, let's find all the fourth roots of these numbers. Keep in mind here, since I'm taking the fourth root, my n value is even, so there's either going to be 2 solutions or none at all. If I try to take the fourth root of 1, my possible solutions could be 1 or negative 1. And if I wanted to backtrack to double check, 1 to the 4th power is 1. Negative 1 to the 4th power is also 1. So those are both going to be solutions here. If I take the 4th root of negative 0.0001, notice if you try that in your calculator, you get no solution. I'm trying to take an even root of a negative number, which, as we talked about, I cannot do. So since my b value is negative, I can't take an even root. I get no answers here, no solution. Finally, if I try to take the 4th root of 16 over 81, my answers are plus or minus 2 over 3. Last thing we'll talk about today, the nth roots of nth powers. For any real number a, the nth root of a to the n is a if n is odd, and the absolute value of a if n is even. So that's kind of a fancy way of saying that if I'm taking an even root of something, and I'm working with expressions, I'm going to want to work with absolute values for a lot of these. And let's look at an example here. So I want to simplify the square root of 16x to the 8th power. I'm taking an even root here, so I'm going to think about including absolute values. I'm going to break these down one term by one term. The square root of 16 is 4. So now I have the absolute value of 4 square root of x to the 8th. Also, I have absolute values here because I'm taking a square root, so I'm going to, this is an even power that I'm working with. Finally, to simplify that x to the 8th, taking the square root, you could think of this like just doing 8 divided by 2 with the powers. I'm left with 4x to the 4th power. Last thing to note here, and this is where this gets a little bit confusing, x to the 4th power, that's an even power. If I plug in a negative number for x or a positive number for x, it's always going to spit out a positive answer. So my absolute values are kind of rendered meaningless here. So my final answer, I can get rid of the absolute values and just say that this is 4x to the 4th power, and I'm done. In this next example, I want to simplify the cubic root of a to the 6th power, b to the 9th power. Since this is an odd power, all I have to do is divide both powers by 3, I get a squared b to the third power. Notice here, since my index is odd, I have no absolute values needed here. So my answer is just that, and I'm done. Finally, last example we'll look at, I want to simplify the fourth root of x to the 8th power, y to the 12th power. Notice again here, since I'm taking an even root, I'm going to want to start out using an absolute value. I divided both of those powers by 2. I'm left with x squared y cubed. And now the last thing here to notice where absolute values would be helpful versus not helpful, anything I could plug in for x, since it's x to an even power, whether it's negative, whether it's positive, will always spit out a positive answer. So I can bring that x squared out of the absolute value. On the other hand, y being taken to the third power, if I plug in a negative number for y, it's possible for me to get a negative answer. So that's why I want to keep absolute values around that y term. And then once I have that, I leave what I need in absolute values in there. My final answer is going to be x squared, absolute value, y to the third power, and I'm done.